If sine x equals a, for x is an element of 0 to pi on 2, find tan x in terms of a. The first thing we should do before going too far into this problem is have a look at the domain of x. So as x is an element of 0 to pi on 2, we know that we're in the first quadrant. Therefore, we know that tan of x is going to be positive. Next, our job is to find the value of tan of x in terms of a. So we've got sine x equals a, and tan x we know is equal to sine divided by cos. So if we can find cos, we'll be able to express tan x. So the relationship we're going to use is the Pythagorean identity, which says that sine squared of x plus cos squared of x is equal to 1. Therefore, sine squared of x is a squared, and then we have plus cos squared of x is equal to 1. And then if we rearrange this by subtracting a squared from both sides, we find that cos squared of x is equal to 1 subtract a squared. So cos squared of x is cos x all squared. So if we want cos x by itself, we're going to need to take the square root of both sides. So we find that cos x is equal to the square root of 1 minus a squared. And that is in fact plus or minus. However, as we're in the first quadrant, we'll just take the positive case of that in a moment. So all that's left to do now is find the value of tan of x in terms of a. So tan of x is equal to sine x divided by cos x. However, we know that sine x is a and cos x is the square root of 1 minus a squared. This is a positive quantity because we know that we're in the first quadrant, and that means that tan x is positive. So that's the value of tan of x in terms of a.